Hi, this is Mr. Max. So today what I'm going to do is I'm going to do some exercises, further exercises on the topic of speed time graphs. So I already have done one particular video. So I'm going to do 6 questions and I suggest that you also write them down and try to work them out, pause the video and see later when you get to the answers whether your answers are exactly the same or correct. Right, so I'm going to bring in a very first question. Now, let me bring the diagram of that particular question. It says that a jackal notices a running ground squirrel and he chases it. Okay, so this is the jackal here, and this particular black line here represents the ground squirrel. So what you can see just from looking at the diagram, that the ground squirrel started earlier, 10 seconds rather, earlier than the jackal. Okay, so you run first, the jackal start chasing it. So the jackal then after 40 seconds, okay, from 10 to 50, that's 50 minus 10. After 40 seconds, all right, after running for 40 seconds, the jackal catches up with the ground squirrel. That's why you can see they are sort of equal here at this particular point, okay? And also what this red dot here indicates is that at this particular juncture, the speed of the jackal and of the ground squirrel is exactly identical. Okay, but remember at this particular juncture, the ground squirrel already covered a bigger distance, so it's not like they are exactly at the same place, just that the speed here is exactly the same. All right, and as you can see also here, for the first 5 seconds, this is a very fast acceleration, and then the jackal speed is constant at 5 meters per second up until the point where it catches up. So there is a lot of action that is taking place here between these two animals. All right, so they are asking the first question, give the time in seconds that the ground squirrel is moving before. Well, that is a very straightforward question. You can just see it from the graph. It's 10 seconds. Then you are supposed to write down the maximum speed of the jackal in kilometers per hour. So the maximum speed that the jackal reaches, as you can see, it's 5 meters per second. But our job is to change 5 meters per second and write it in kilometers per second or kilometers per hour. So the objective would be change meters into kilometers. All right, so I know that 1 kilometer is equal to 1,000 meter. I always say do what you know, and from there you know you're supposed to divide. And I also know that you're supposed to change an hour to seconds. So 1 hour is equal to 3,600 seconds. All right, so in order for you to represent 1 second, because that's effectively 1 second there, you put 1 over 3,600. So from here on, you can just now take that distance divided by that time, and then you have your answer as 18 kilometers per hour. All right, so let's continue with the current question. Now, the part C says you're supposed to calculate the acceleration of the jackal before reaching the maximum speed. Okay, so before reaching the maximum speed, which was at 5 meters per second, you're supposed to calculate the acceleration. So effectively, what that is, you take this 5 meters per second and you divide it by this distance here, very important, is 5. So it's 1 meters per second squared, that is the acceleration. Okay, now you're supposed to calculate the distance the jackal has to move before catching the squirrel. Okay, now this is very important, the distance that the jackal has to move before catching the particular squirrel. Now we're going to find the area under the graph. Now this is one of the things that I would suggest that you get used to whenever you're dealing with these questions here that I'm going to do. I would suggest you get used to calculating the area, or know the formula to calculate the area of a trapezium. Now a trapezium is the sum of the parallel sides, okay, and you multiply that by the height and you divide by 2. Sometimes this very formula is written as a half, which is this 1 over 2, and then the sum of the parallel sides, okay, a plus b, times the height. It's exactly the same thing. So make sure that you do know this. So when you look at the distance of the jackal here, so I'm talking about this particular trapezium here. So it's here all the way here. So
you can go ahead later on and divide them into triangles and rectangles. All right, so we're looking for this area here. So what I've calculated, then I know that this distance here must be 40, and I get that 40, all right, from subtracting 10 from 50. And that is the distance that you see here with the particular 40 that I have indicated here, okay? So that's what you see here. So this 35, okay, comes from nothing but this particular distance from here all the way up to here, okay? So that is the distance that you see there, all right? So it is basically this particular 15 that is down here. For this is where it's going to be. So you're going to take that 50 and you subtract 15, all right, and then you get the 35. So that is what I've done there. So I know my 35, I have my 40, and the only other thing that is important is to calculate the height, and the height here is the 5 that you are seeing here. All right, the height is the 5. Obviously you're getting that from your graph. All right, but again, as I say, it's totally up to you in this particular case whether you want to divide your graph, because remember, whatever is under the graph is how you calculate the area in a speed time graph. So if you wanted to, you could also have decided to say divide it into rectangles and also triangles. So you could have decided, let's take this triangle, then you work out this area of this triangle, then you take the rectangle, okay, then you take the rectangle here, and then you calculate the area of this rectangle, all right, and then you simply add them together. It will still also bring you 287.5 meters, okay? But it's just that for this questions that I'm going to do here and so on, I'm going to use the formula to calculate the trapezium, because most of the time the formulas that you will see or the shapes that you see under the graph is going to be a trapezium. Right, so let's bring that back again for the last time. It says calculate the average speed of the jackal during the chase. Now here's the thing about average speed. So what average speed is, we know already that the total distance that the jackal covered from our previous question was 187.5. Okay, we know this. This was our distance. Now what we need to find is the total time. So the total time, you get it from your graph, okay? So the total time, it did it in 15. Total time, it did it in 40. Okay, 40. So the total time is from 10 and the 50 here. So it did it in 50 minus 10, which gives you 40. So it did it in 40 seconds. So now you have your answer, and then you can simply find it by dividing, because that's how you find the average speed. So I'm going to bring in the stuff that I typed here so that you can see exactly how that particular question is supposed to be answered. All right, so the average speed takes into account the total distance divided by the total time, and you divide that and your answer will be meters per second. That is the average speed. If you calculate on average what was the speed of the jackal here. I believe there is still one more question. Right, so part F, the first one they are saying you must explain what happened here. So is this basically, as I said already in the introduction of this particular question, the speed of the ground squirrel and the speed of the jackal are exactly the same. They are equal, but it doesn't mean they are at the same place, okay? This ground squirrel already covered the distance here. It's just that at this particular time, okay, or at this particular instance, the jackal speed is equal to the speed of the ground squirrel. Right, the second question here, the graph shows the speed of a truck and a car. The truck, you can see constant speed of 12 meters per second. The car accelerates here and obviously there is that deceleration there. Okay, so now this particular question asks us to find the first thing, the acceleration of the car during the first 45 seconds. So that is obviously all the way from here up to here. Remember, acceleration is nothing but gradient. Gradient is the vertical distance, 36 divided by 45. All right, so once you do that, you get 0.8 meters per second squared. That is going to be the acceleration of the car during the first 45 seconds. Okay, so remember, look at the previous video, and so you don't get confused, acceleration or deceleration is exactly how you calculate the gradient, where you take vertical distance and you divide it by horizontal distance. Right, so now they are saying we're supposed to calculate the distance traveled by the car while it was traveling faster than the truck. So the graph can be a little bit misleading, but what this particular question is all about, it's particular this area here that we are going to find. So we're going to find this area here, okay, and also because it has to be the area under the graph, and also it's going to be this particular area here. Okay, so once we have this particular area, because it includes the total area under the graph when the car was faster, as you can see, faster. So it's that particular area, that one here, all right, when it was faster than the truck. So everything under that particular, you can say that roof, so to speak. So that is the area that we are going to figure out. And in order for us to find the area, we can have a rectangle here. We can have maybe two right angle triangles, or you can find that area of that triangle and you add them all up. All right, so that is how we are going to do this particular question. Right, so again, I said it's just the area under the graph where the speed of the car is higher than the speed of the truck. So these points of intersection means that whole particular area there. Okay, so I have done it in this way. I took a right angle triangle here, so I know this is 30, and you can calculate this 30 here by taking 45 here minus 15. Very important that you know the what does one small square represent, okay? And on the other side, so I've done it, I get 360 meters. Remember, the formula to calculate the area of a triangle is half times the base times the height. Then I bring in the second one here. So this is 10, obviously, because one little block represents 5 seconds. So this is going to be 10 seconds. All right, so that's why I have 10 here, but the height is still the same as 24, the other one. Okay, then the third one that I did here is the area of the rectangle, and to find the length here, I got 55 here minus 15, so I know that it's 40, and I know that height there is 12, so multiply 12 by 40, that gives me the area of the rectangle, which is the area, which is equal to 480, since we are looking for the distance, and we know that in the speed time graph, the distance is the area under the graph. So now, the only thing that you need to do, because you're supposed to calculate the distance traveled by the car, you have to take while it was traveling faster than the truck, so it's going to be that 360 plus this 120 plus that 480, which gives you 960 meters. Right, I have a third question here. So it says the diagram shows the speed time graph for part of a car journey. Now I have done this particular question in two ways, and I will explain both methods. It's totally up to you which particular method you prefer. All right, but there's an anomaly here, and I want you to be a bit careful with this particular graph here. Now what you need to see, number one, is that the time that we are given here is minutes, while the time we're given here is hours. So it is not compatible. It's not the same. So somewhere there will be a question and a probability that we need to find the distance, okay? And in order for us to find the distance, we need to make sure that the units are the same. It's either both of them are minutes or both of them are hours, okay? Otherwise, you can't have different units while you are solving the particular question. Right, so they are asking us here to calculate the distance traveled by the car during the first or during the 3.5 seconds. And this is exactly what I'm saying. We're supposed to calculate the distance Okay, so calculate the distance. So in order for us to find the distance is the area under the graph. Now here's the thing about the area under this graph, and so you get an idea, right? So you can take, like what I did here, I can also find the area of this whole rectangle from here to here. Okay, so you find the area of the rectangle there, and in order for you to find the area of the rectangle, you will have to multiply, and this is where you need to be a bit careful, and this is exactly what I've done. So I know that the area of a rectangle is this height, which in this particular case is 100, but it's kilometer, okay? All right, and here, to find this particular distance from here all the way up to here, all right, you have to change this time to hours. Okay, you must change it to hours. So 3.5 minutes, if you divide, because 1 hour is equal to 1 hour is equal to 60 minutes, then you should get something like this. So this answer now will be in hours. It's only then that I'm going to multiply those. Okay, but I'm going to bring up the solutions for you to see exactly what I've done there. Then the next thing you can do, all right, also just a method that you can approach. You can find the area of this triangle, which is identical to area of this triangle, and then you add them all up, and all of that will give you the distance. All right, that's one way of doing it. Another way of doing it would be if you were to find the area of a whole complete rectangle. Okay, so what you need to do with this particular method, you can find the area of this rectangle from here. Maybe I should bring in a highlighter so that it's a little bit more straightforward for you to get an idea as to what I mean. So you find the area of the whole complete rectangle, which is all the way from here up to here, the area of this rectangle. Right, so what that will give you, it will give you the whole distance. So in order for us to find the area of that, again, we must make sure that our times are changed, all right? But it's going to be a little bit different. It's going to be our height now. In this particular case, our height is going to be, if you look at it, our height will be all the way from here to here, which our height is 120 kilometers, okay? And then that's the height of the rectangle. And to find the distance from here all the way up to here, which is 3.5 minutes. All right, remember from my previous, I said you get to 7 over 120 when you write it in hours. Okay, the way you find this is you take 3.5, you divide by 60, then you multiply, you find the area of this whole rectangle here, the whole rectangle. All right, so once you have found the area of that rectangle, you must make sure the units are the same. Okay, then you are going to subtract now, because I found the area of that rectangle. So that is I'm just giving you an overview of what is it that I have done. Remember, I said I have done them in both methods for you so that you can get an idea. So now if you have the area of the whole rectangle, then you go ahead and you calculate and you find the area of this particular trapezium. It's a trapezium, this one here on top. Then if you find the area of the trapezium here, all right, then you subtract it from the area of the rectangle. But now let me just talk about a trapezium again. So when you are comparing your trapezium now, you will notice that the height of the trapezium here is nothing but 120 minus 100. So the height here is 20 kilometers. Okay. But now, when you are looking at this particular distance, we already know from our previous, this distance here, 3.5 minutes, we have the same as 7 over 120, okay? Where does that come from? It comes from taking 3.5 minutes and writing it over 60 minutes, okay? Now, here's the other one that needs to be changed, and is the distance from here all the way up to here. So this distance here is nothing but 2.5 minutes, okay, because you have got this little 0.5 here, you have got this little 0.5 that you're supposed to subtract. So this is what we have, and then again you must perhaps change this 2.5, all right, and you then also write it in hours. Okay, and when you write it in hours, then you can now find the area of that trapezium. And once you find the area of the trapezium by using the formula is the sum of the parallel sides times the height divided by 2, and then you subtract the 2. Okay, so I know it sounds a little bit confusing and trivial, so I'm going to go through them step by step. Again, as I said, both methods. I'm doing both methods in order for you to see how I managed to get to the answer. But remember the keyword, and that's why I left this in this highlight put part on, for you to know that the units are not the same. And in order for you to work this out, this problem, you must make sure that the units are the same. Okay, so it is very important, otherwise you find yourselves making a very big mistake, and whatever you do will just be wrong. Okay, so that first part that I was doing, now this particular slide, I'm just going to show you roughly how to get to the answer, the 3.5. So I'm taking the area of the rectangle, which was the whole area from here up to here, 3.5 over 60, because it has to be in hours, all right, times the 120, so the whole rectangle. Then I subtract the area of the trapezium. Now the trapezium, okay, is going to be the sum of the parallel sides, which is this particular distance of 2.5, and that particular distance of 3.5. I put it over 60 because it's supposed to be in hours, all right? So the sum of that times 0.5, a half, all right, divided by 2, times the height, and the height there is 20. Right, once you do this, you're going to get to an answer of 6 kilometers. So I'm going to do this particular question step by step on the next slide for you to see how, using this method, you get to this answer, just to clarify any problems that you might experience. Right, so let me bring then that the top part, which is that little trapezium there. And we know that that is 3.5 minutes, and we also know that this was 2.5 minutes. And what we also know is that height there was 20 kilometers from our previous graph. Okay, so then the area of this trapezium is the sum of the parallel sides times the height, okay, and divided by 2. This is the formula. So I added these two here times the height of 20, right? But I have got 5 minutes, and I have written this in red here so that you can see I need to, before I continue, I must change this 5 minutes into hours. So I did my side work. I take 5 minutes is exactly as 5 over 60, because it's not a complete hour, which is about 1 over 10, which is 0.1 hours. So I'm going to sub 0.1 in here. All right, so this 5 minutes is 0.1 times 20 divide by 2. So this gives me the distance, and that is the area. That's the distance that we're looking for. Okay, then if I bring my rectangle in again, the rectangle, this whole distance here, it's 3.5 minutes. Remember I said it's 7 over 120. How do you get it? You take 3.5 minutes and you divide it by 60. Okay, the same like I took the 5 here divided by 60, because 5 minutes is 0.1 part, it's 0.1 of an hour. Okay, so once I have that distance now, and now I will also consider my height. So the height of the whole rectangle with this little part is in here somewhere. Okay, it's in there somewhere. So when you calculate the area of the rectangle, I get that 7 over 120 times 120, I got 7 kilometers. So in order for me to find that part on top, you do your subtraction and you get to 6 kilometers. That is exactly what I meant by how you can do that one using this way. Maybe we should try the alternative method, which might be a little bit easier for you to understand. So alternatively, if I bring my graph back, so what I did here is I bring in a triangle here, and I bring another one here. So what I realize is these two triangles will be identical. Okay, so if I take them and I flip them around, and I know that the height here is going to be nothing but 20 kilometers. Okay, and now I'm interested in this little part distance here, which is the same as 0.5. Can you see that? But it's minutes. So if I change 0.5 minutes to hours, it's going to be the same as 0.5 over 60, which simplifies to 1 over 120 hours. Now, if I calculate this area here of these two, okay, I'm going to get 2 over 6 kilometers. Okay, 2 over 6 kilometers. So if I take that, I get 1 over 6 kilometers. Okay, if I take the area, I take that 20 kilometers times 1 over 120, okay, and I'm going to get that particular answer. Now, then I bring in my rectangle. And remember what I said from the previous, this distance now is 7 over 120 in terms of hours. Okay, and now this height here is nothing but 100. That's why I multiplied by 100. So when I've done that, all right, I'm going to take this 35 over 6 kilometers. So I have not written it down as a fraction because it becomes irrational, all right, as a decimal. So I'll take 35 over 6 and I'm going to add 1 over 6. And the moment I add 35 over 6 plus 1 over 6, I am going to get 6 kilometers. Okay, so I'm going to let it pause and then you have a look there to see what is it that you needed to do there. Right, let me bring in question 4. So a car starts from rest and accelerates for u seconds, and it reaches a speed of 10 meters per second, constant speed. The car then travels at this speed for 2u seconds. How do you get 2u? Well, it's 3u minus u gives you 2u. All right, so this diagram shows that. So they are asking us to find the value of u. So what they have told us here is that the area of this trapezium is equal to 125 meters. Now, you can, if you're interested in, you can find the area of the triangle. You can find the area of the triangle, then the area of this rectangle, okay, and then you add them and let it equal to that in terms now of u there. So basically, the first one here for 1, it's going to be half times the base. Now your base is u times the height, and the height is 10. Okay, and a half of 10 is 5, so that gives you 5u. And if you do the one for the rectangle here, so the rectangle, it's the area of the rectangle is going to be nothing but the height or the length, which is, now remember, it's 2u. Okay, that is the distance from here all the way up to here. It's 2u. All right, the way you find it is you say 3u minus u. All right, so it's 2u times, now the height here is 10, okay, and that gives you 2u times 10 gives you 20u. All right, so now you have got your area here of the rectangle, your area here of the triangle. Well, if you add them up, okay, if you add them up, you're going to get like terms. It's going to get 25u, and we are told is equal to 125. So the only thing for you to do is to find u, and you say 125, okay, divided by 25, and then it's going to give you for u an answer of 5. So this is what you could have done if you decide to go that way. Okay, but what I have done, it's easy also to do it like this, but what I have done is I have just taken the area of the trapezium. So I know the formula to calculate the area of the trapezium, and I use that to calculate my answer straight. Anyway, you still have to get to the same answer of u equals to 5. Okay, so the area under the graph. So what I've done here, I just brought them in a small diagram so you can see I know how to calculate the area of a rectangle, sum of the parallel sides, which is 2u plus 3u. Okay, that gives you 5u times 10 divided by 2. I wrote that over 1, so cross multiply, you can do that. 125 times 2 is 250. All right, and then the 5u comes from that, multiply that, you get, now then I divide by 10. Okay, then I get 25 there, and obviously 5 goes in 25 5 times. So that is one way that you could have done this particular question, as long as you get to the same answer, to the same solution. Okay, this question is a little bit straightforward. No need to be afraid of it. Now let's look at the second part where they are asking us now to find the acceleration in the first u seconds. So what I did is I took away my u. I know that u is 5 from my previous answer, and here, remember, was 3 times 5. But they're not really interested in the 15. They're interested in the first u seconds, in the first 5 seconds. So acceleration is nothing but vertical distance divided by horizontal distance. Then divided by 5 gives you 2 meters per second square. Remember the unit for acceleration.
Right, question 5 here, another diagram, and they're saying here, they shows the speed time graph for 15 seconds for the journey of a cyclist, okay? So you can see from 0 to 4 seconds, he was accelerating, and then here 3 meters per second, that was his constant speed, and he did that for the next 11 seconds. Where do I get 11? Well, I get 11 by subtracting, okay, 15 here, minus 4, then I get 11. So I know that this 11 here is representing the distance that is up there. Okay, so let's see what the question asks or demands that we do or ask us to do. All right, so we then are supposed to calculate the acceleration for the first 4 seconds. That is very easy. It's just going to be 3 divided by 4. Okay, that could give you 0.75 meters per second square. Right, vertical distance, remember gradient divided by, yeah, that's 3 divided by 4. Okay, so the second part to this particular question, you're supposed to calculate the average speed for the first 15 seconds. You have to be a bit careful with this formula here. The average speed is the total distance. So we need to calculate the total distance, all right? And the total distance divided by the total time. All right, so I talked about at 11. So the total distance is just the area that I have here. I could have taken the area of this, the area of that, add them up, you should get 39 meters. So we remember total distance divided by total time. So the formula is the 39 over 15 total distance divided by the total time gives you 2.6 meters per second. That is the average speed that the cyclists have done. Right, question 6. So a train journey takes 1 hour. The diagram shows the speed time graph for this journey. Okay, 1 hour, 0 to 60 minutes. Okay, all right, and you can see that the speed that it maintained after 3 kilometers was that 3 kilometers per minute. Okay, my units are the same, nothing to be afraid of. All right, so calculate the total distance of the journey. So you can decide, okay, I take this area of this triangle, this area of this rectangle, this area of this triangle, add them all up. Or essentially, I can also realize this is a trapezium. Okay, so this is a trapezium because the formula to calculate the area of a trapezium, remember, trapezium is nothing but as long as they are parallel sides, and these sides are parallel. So I take that 46 there, and I have got, now here is going to be 60, all the way 60, and the height here is nothing but that particular 3 that you are looking at. So the height is that 3, and that's why you see I have done that particular case. All right, but remember, as I said, no problem, you could also have decided to take the area of this triangle, take the area of this rectangle, take the area of this triangle, and add them all up. And if you add those areas, you should still get to the 159 kilometer. Okay, like what I have done there. Right, so the second part of this question, they are saying you're supposed to convert 3 kilometers per minute into meters per second. So 3 kilometers, what does it equal to in terms of minutes? It's 3,000 meters. Sorry, in terms of meters. Okay, and what is 1 minute in terms of second? Well, 1 minute is equal to 60 seconds. So now it's very straightforward. 3,000 meters divided by 60 seconds, so 50 meters per second. So this speed of 3 kilometers per minute is the same as 50 meters per second. Okay, that's basically what it is. So we're going to use this answer in the next part when they ask us the next question. Right, so they are asking us to calculate the acceleration of the train during the first 4 minutes, and they want our answer to be in meters per second. So first I change 4 minutes 2 seconds because my answer should be meters per second squared. All right, so I know that that is 240, and I know from my previous work that 3 kilometers per minute is equal to 50. Remember, we've calculated this one, okay? We have worked it out. So this here is 50 meters per second. All right, so now this one here represents nothing but 240 seconds. So we can actually then calculate it out. No? All right, so I brought it in terms of a triangle here, so you can see we're looking for this particular gradient. Okay, the acceleration gradient is nothing but vertical distance divided by horizontal distance. Obviously that gives you 0.208
333 and so on, but you can write it 3 significant figures as that particular answer. Right, so have a look at all 6 questions again. Try to do them on your own. Then you refer back to the video. And if you manage to get them right with this and the previous video, then you should be on the right track.